In May 2007, a Ford TSB told the story that commonized 20mm heads were going to be found in service situations, replacing the 18mm heads. This is an interesting change which required a rocker box change and injector hold-downs. The hold-downs moved to prevent cracking of the heads above the injector cups, but there were other casting changes hinted to. The new heads also have the core plugs changed from 28 to 32mm, a significant change if you understand foundry operations. Without disassembling parts of the motor, you can check if you have the commonized heads by measuring the core plug size in the front of the motor. This engine has the 20mm heads, and I'm happy it does. Neither of the heads showed the traces of the typical head gasket failure, blowout in the center of the head, and I never experienced the symptoms of that issue. Mine was a valve train issue. If you thought the short block videos were down the rabbit hole, the heads ended up that way too because of my project drift. Alice got left at the first level down this rabbit condo. It no longer became a just get the motor back in the frame. This video segment is mostly about cleaning the heads and the initial checking if they were crowned or tented, which would require machining, an expense I'm trying to avoid, which means a deeper hole. So part 1 is at the level that dealership techs would have encountered at the warranty phase given their restrictions. I had the following details in my block deck video, but the narrative was written for this video. I've just copied and pasted, so it's redundant if you're familiar with that video. Initially, International and Ford wrote in their service manuals to use non-metallic brushes and scrapers to clear the surfaces. But I think with dealership service personnel using razor blades, steel bars, and rotary abrasives, discussing that online, a new TSB was released by Ford, basically reinforcing the narrative in the manuals. Not to use steel scrapers or razor blades, which can scratch or gouge, providing pathways for combustion gas to flow and bypass the sealer. They also don't want anyone to use rotary abrasives or abrasives in general. I never use a rotary abrasive tool on the decks or heads. I will use them on other surfaces that are not as critical for flatness. To me, this is just not a problem-solving technique. Ford now insists you use a brass scraper, so we've changed from using non-metallic to non-magnetic. I have a brass scraper, but typically don't use it for this. The Scotch-Brite 96 pads I've always used in cleaning. It's a good scrubbing tool. Ford is okay with surface staining, but I'm not. My viewpoint is any debris left behind can affect the adhesion of the gasket sealant. They state impressions from the previous gaskets are acceptable, and I've never worried about those. I'm also okay with corrosion and erosion of the coolant areas not impacted by gasket sealing. I place paper towels on the surfaces I'm going to clean, then soak them with the spray gasket remover. This prevents the spray from going into areas that are difficult to clean. I then cover the paper towels with plastic so the chemicals won't evaporate quickly. And I can let this soak for hours. Sometimes I respray the towels during this period. I typically use Goodson Super Scrapers. If you look at some of Felpro's videos, they're in the background. They have a carbide block on the end to maintain their edge, and they clear the surface by plowing the debris off. Properly used at a low angle, I've never developed scratches. But they cannot clear out the material that's within the machining marks or shallows, and that's where the Scotch-Brite comes in. It appears no one ever shows the process of scraping the heads. Some respected people mention razor blades, flat bars, whatever Ford says not to do. Maybe it's not shown due to liability concerns. They expect people to have experience, or they know it's damn boring to watch. I'll show what I do since I'm not following the narrative Ford or International have stated, and how it worked out if you're interested. You need to have patience to do it my way, which should motivate you to have a machine shop do this in the first place. Even if I was not posting a YouTube video, I still would have videotaped this inspection so I could use my 27-inch monitor to examine this more closely. The cell phone visual tools can be good for close inspection. All of the blue silicone rubber has been removed, and we are left with carbon and iron stains. For me, the heat coloration around the valves is interesting. Some debris remains in the milling grooves, but there aren't the gouges that Ford was concerned about. You just have to be careful. I used 2 hands to ensure the tool was flat to the surface and the corners of the scraper would not bite. I'm also doing a visual check around the region of the valves to the injector and glow plug holes. This region has the highest stress concentrations after the valve seats are induction hardened, and the milling marks this head has could propagate into cracks. This is just a preliminary check. At any stage of working these heads, I could find an issue that would require me to send these to a machine shop or to buy new heads. Next comes a preliminary check of the flatness across the width of the heads. For this I'm targeting 1/1000th of an inch, half the tolerance. While I'm doing that, I realized I should have removed the rust buildup at the extreme edge, which is lifting the straight edge and provides more clearance under the bar. Still with that, they meet my 1/1000th of an inch spec. I have no issue with Ford's statement that a longitudinal check is not that important. I think they know something they are not telling. The band of rust I need to remove exists in these areas. I am not going to use my carbide scraper for this. Felpro's video mentions never to use these type of abrasives on a header block. They do talk about using a fine wire, steel brush, and an air grinder. That's a bridge too far for me. I've never had an issue using a fine wire brass wire wheel, as it's very soft. You could probably use it on the sealing surface as it's so gentle, but I won't do that. The wires on this brush are 6/1000ths of an inch. So now I'm back with applying another round of gasket remover and letting it sit for some time. Then I use the Scotch-Brite 96 pads as a scrubbing tool, as it will collect the debris, similar to steel wool when refinishing furniture. And it's on Ford's approved list. And the surface mess is cleaned off with paper towels as I work the surface. I did this routine of gasket remover and Scotch-Brite a second time. This is what remains. I did have a few areas where the surface was burnished with the scraping tool, but not gouged. I'm not concerned about those areas. It's the high points of the machining threads that are flattened. Occasional bright lines are not gouges. Just some debris or rust particles that got dragged with the Scotch-Brite, clearing the staining. One thing that is very visible now are the milling tool marks. I could understand if someone thought this is the surface that Ford talks about not to disturb. I don't think it is. Let's take a look at the driver's head after scraping. This is a totally different surface. Milling marks are wide with a scalloped appearance in certain areas, which escaped clearing the sealer due to the shallows. I'll show again after one round of Scotch-Brite cleaning. I'm highlighting the scalloped areas, but the overall sheen of the surface is high. It's very smooth. You can often tell how well a cast product is machined by its sheen. Tooling that tears out the metal rather than cutting it will leave a flat sheen. It's the easiest way to tell if the machinist knows what he's doing in setup and changes out the bits as they wear. The head with the milling lines does have a sheen, but it's interrupted by the lines. These two heads were machined with different setups and different tooling. The fly cutter bit will matter, the feed and RPM will matter, and how the tram of the mill is set up will matter. Some fly cutters are more stable than others. This particular fly cutter is one bit with a rounded cutting edge. You could also have a CBN cutter, in this case round. It gets rotated as the cutting edge wears. Depending on how a fly cutter is trammed to the table, you can have marks from both the leading and trailing cuts. If it does, the fly cutter would have to go past the object it is machining to have a consistent finish. And you can see that in the pattern in this passenger side head. It's showing both leading and trailing lines in the surface down the entire length. Notice in this video, once the fly cutter finishes its leading cut on the cutting pass, it returns to the starting point. No trailing marks are being generated. You can tram a mill head so the fly cutter sits lower on the leading and higher on the trailing edges, adjusting the heel. It will, however, cut a slight bow in whatever you are machining. The valley can be lessened if the fly cutter is wide, and the object you are machining can tolerate the valley in its flatness specification. You may find that an automotive machine shop might set this at 5/10,000ths to 1/1000th of an inch. The result is a cylinder head. Like with the 6.0, there is a lower compressive force in the center line of the head due to the bow and the surface. And all the higher tension fasteners in the world, and that includes big dollar studs, can't adjust for that. Something to think about if you've experienced a second head gasket failure. Just because it was machined doesn't mean it's flat, or the surface finish is right. So even freshly machined heads should be checked for flatness. Take a look at the driver's side head. It's been surfaced with a rounded bit. It presents a much smoother surface. So which is the surface that Ford is warning to protect from scraping and machining in the field? Because they don't want these heads machined. Just ask any Ford technician or mechanic. These two finishes are not the same at all. Part 2, surface finishes and lapping. If you made it this far, thanks for watching.